Elon Musk wants to die on Mars. NASA wants a permanent colony there by the 2030s. We've sent rovers, we've sent drones, and we've mapped every inch of its red, dusty surface. But here is the cold, hard truth that nobody wants to admit. As of today, sending a human to Mars isn't just a challenge, it's a potential suicide mission. While you're watching this, thousands of scientists are grappling with a reality so brutal it makes the moon landing look like a weekend stroll in the park. Why, after 60 years of space travel, are we still stuck in Earth's backyard? What is the red wall that we simply cannot break? The answer isn't just about rockets, it's about biology, physics, and a terrifying 140 million mile gap that wants to kill us in a dozen different ways. To understand why Mars is so hard, you first need to understand how small our space age really is. We think of the International Space Station as deep space. It's not. The ISS orbits just 250 miles above our heads. You could drive that distance in 4 hours if your car could go vertical. The Moon, that's 238,000 miles. A long way, sure, but we got there in 3 days using 1960s tech. But Mars is a different beast entirely. At its closest point, it's 34 million miles away. At its farthest, it's a staggering 250 million miles. Imagine a journey 1,000 times longer than a trip to the Moon. If the ISS is a grain of sand on your doorstep, Mars is a mountain on the other side of the continent. Every extra mile means more fuel. More fuel means a bigger rocket. A bigger rocket means more weight. It's a vicious cycle of physics that we call the tyranny of the rocket equation. To get a small group of humans to Mars, we don't just need a rocket, we need a flying skyscraper. You might think we can just launch whenever we're ready. Wrong. Because Earth and Mars orbit the Sun at different speeds, they only align once every 26 months. This is what scientists call the launch window. Miss that window by a few days, you're stuck waiting another 2 years. But here's the kicker. Once you get to Mars, the planets move. You can't just turn around and come back. You have to wait on the surface for about 16 to 18 months for the planets to align again so you can actually reach Earth. Total trip time, roughly 3 years. 3 years in a tin can. No grocery stores, no fresh air, no escape. Let's talk about your body. Outside the protective magnetic field of Earth, space is a shooting gallery of high-energy particles. Cosmic rays and solar flares are constant. On a journey to Mars, a pair of astronauts would be bombarded with radiation levels equivalent to getting a full-body CT scan every 5 or 6 days for a year. This isn't just a cancer risk. This is brain damage. This is the degradation of your central nervous system. This is your DNA being unzipped by invisible subatomic bullets. And then there's the gravity, or lack of it. 6 months in 0G causes your bones to turn into Swiss cheese, your muscles wither. Your heart, no longer needing to fight gravity to pump blood to your head, actually begins to change shape. By the time you land on Mars, you might be too weak to even stand up in your spacesuit. But what if we had a ship that was big enough to carry everything we need? Enter SpaceX's Starship and NASA's SLS. Elon Musk's Starship is the largest flying object ever built. It's designed to carry 100 tons of cargo. But Starship has a secret problem that most people ignore. It can't get to Mars on 1 tank of gas. To make the trip, SpaceX has to perform something never before achieved: mid-orbit refueling. Imagine launching a giant rocket, then launching 5 more rockets just to fill the first one up with gas while they're both screaming around the Earth at 17,000 miles per hour. If one docking maneuver fails, the mission is dead. If the fuel leaks, the mission is dead. We are betting the lives of our pioneers on a gas station in the sky that doesn't exist yet. Let's assume you survive the radiation, you survive the bone loss, you survive the refueling. Now comes the hardest part, the landing. Mars has an atmosphere, but it's 100 times thinner than Earth's. It's thick enough to burn you up on entry, but too thin to slow you down with parachutes alone. When NASA landed the Curiosity rover, they called it 7 minutes of terror. They had to use a heat shield, a massive parachute, and a literal sky crane rocket-powered backpack to lower the rover gently. And that was for a 1-ton rover. A human mission will weigh at least 20 to 50 tons. We don't have a parachute big enough. We don't have a heat shield strong enough. Right now, we are trying to figure out how to slam the brakes on a house-sized spacecraft falling at 12,000 miles per hour into a bed of rocks. Beyond the tech is the mind. On the ISS, you can see Earth. It's right there, big, blue, and beautiful. On Mars, Earth is just a tiny, pale blue dot. It's a speck of dust in the blackness. Imagine the isolation. If something goes wrong, a radio signal takes 20 minutes to reach Earth and another 20 minutes to get an answer. There is no "Houston, we have a problem" in real time. You are truly, terrifyingly alone. We remember the Challenger. We remember the Columbia. Those were simple missions compared to this. The history of space exploration is written in blood and sacrifice. So why haven't we landed on Mars yet? Because we are still learning how to keep humans alive in a place that is fundamentally designed to kill them. We are waiting for the technology to catch up to our ambition. But make no mistake, one day a human footprint will mark that red soil. Not because it's easy, but because the urge to explore is hardwired into our DNA. The question isn't if, it's who will be brave enough to take that one-way ticket into the unknown. If you want to see the moment we finally break the red wall, hit that subscribe button and join us as we track the future of the Starship and the Artemis missions. What do you think? Is a one-way trip to Mars worth the risk, or should we fix Earth first? Let us know in the comments below.